Okay, so let's do this multiple choice question, and I am recording, so I want you to stop talking back there. Thank you. It says, the graph above shows the velocities of two objects undergoing a head-on collision. Given that object 1 has 4 times the mass of object 2, which type of collision is it? Is it perfectly elastic, perfectly inelastic, or cannot be determined? So now, to review a little bit, so let's review collisions. And I'm probably off screen, yeah. Well, let's just review collisions a little bit. When you have a collision, you have elastic collisions. Now, one of the options was perfectly elastic. That doesn't really make sense. If it's elastic, it's perfect. It's perfectly elastic. There's no like almost perfectly elastic. It's just elastic collisions. And when you do that, when you have an elastic collisions, two objects come together and they fly apart. They push on each other, right? We have that conservation of momentum where they go bam, equal and opposite forces for the same amount of time. That's equal and opposite impulses, which means equal and opposite changes in momentum for each object, which means when you add those changes in momentum together, there's no change in momentum at all. So when you have an elastic collision, the initial momentum of the whole system equals the final momentum of the whole system. Also, if you have an elastic collision, we're not creating any heat. No, we're not heating the environment. There's no sound. There's no like random vibrations that are moving off into the environment. Everything's just perfect, and so that the initial kinetic energy of your two objects before the collision equals the kinetic energy after the collision. And that's what defines an elastic collision. If you have an inelastic collision, it's the same thing. The initial momentum equals the final momentum. That's always true. But the initial kinetic energy will be greater than the final kinetic energy. You're going to lose some kinetic energy. Now, if it's perfectly inelastic, okay, it's same thing. P initial equals P final. K initial is greater than K final. That's still true, but the two objects stick together before, so they come together and they stick together afterwards. So V final for 1 equals the V final for 2 equals just some common final velocity. They stick together. When they stick together, they have lost the maximum possible amount of kinetic energy. Now, here's how you can lose all of it. So let me zoom out a little bit. So if I have two objects that are coming together like this, equal and opposite velocity, everything's the same, and then they stick together. I think we did this with the cars, where you had Velcro and they stuck together. Well, the final kinetic energy is 0. They're not moving. Now, both of them were moving before, but now they've stuck together, so the final kinetic energy is 0. So depending on what your frame of reference is, when they stick together after the collision, you have lost the maximum possible kinetic energy, and so therefore we call it perfectly inelastic. But in this problem, you can see that the objects have not stuck together, because object 2 has a velocity of, looks like a final velocity of 3 meters per second, and object 1 is now moving at -2. So they don't have the same final. They bounced off each other. They came together and then they bounced off, and now they're moving apart. So it's not perfectly inelastic. Now, so that means it's, maybe it's an elastic collision, or maybe it can't be determined. Let's find out. Let me zoom in here. You can see it better. Now I'm going to actually write on this. So let's figure out, let's see the objects. Object 1. Here's object 1. And let's see what its kinetic energy is here. Object 1 has 4 times the mass of object 2. So object 2, I'm going to give it a mass of m. So what's the kinetic energy of this, of object 1? Well, it's 1/2 4m times 6 meters per second squared, right? K equals 1/2 mv squared. So this is, well, 2 cancels with a 4. That's 2m times, and what is 6 squared? 36. So that's going to be m times 72. So that's the kinetic energy of object 1. What's the kinetic energy of object 2? Well, it has 4 times, this one had 4 times the mass, so it just has 1/2 mv squared. What is its velocity? 1 meter per second squared. So this is 1/2 of m. So when you add them together, m times 72 plus 0.5 m's, you get 72.5 times m. That's the kinetic energy before the collision. Now it's kind of a weird way to do it because we don't know what the mass is. And if that really bothers you, just give it a mass of 1 kilogram, and this would be 72.5 joules. Now let's look at it after the collision. It's 1/2, what is the mass of object 2? It's just m, 1/2 m, and it's 3 meters per second squared. And then what is this one? Well, it's 1/2 4m, it's got 4 times the mass, but it's now only moving -2 squared. So this is 3 squared, that's 9. What's 1/2 of 9? That's 4.5 m's plus, and then what is this? This is 2, that's 4. 4 times 2 is 8 m. So we get 12.5 m afterwards. So look, before the collision, I had 72.5 m of joules. Here I only have 12. So I've lost a lot of kinetic energy, but they're not stuck together. That means that it's an inelastic collision. The answer is C. Now I spent a long time explaining that. You'll only have about a minute to figure that out on the actual AP test. Minute and a half. Any questions? Let me zoom all the way out. Let's take a look at the whole thing. That is